Hi.
Hey, well, it looks like it's just you and me. So if you want to talk about your project, let's go ahead and talk about it.
Okay. Should I just share my screen or?
That would be good.
Oh, you have to allow me, it says.
Oh, I keep forgetting that security thing here. Let's say security and share screen. Okay.
Okay.
Well, this looks
So,
good.
oh, it does good.
Yeah, no, this looks really good.
Okay, because I had a couple that I wasn't sure about. Like how I did here, the customer preferences, and I put all the preferences in, or if I needed to do it this way, where I just put, um, sorry, I guess just the form, and then I guess in the column and rows, then they'd be listed. I'm just not sure.
So I'm looking at two. Okay. Okay, let me see. Off the bat, what I'm seeing is okay. So the ones I'm looking at right now, got customer concerns and customer preferences, right? I'm looking at that and thinking that when you look at customer concerns, you got dryness, redness, anti-aging, and acne blemishes, right?
Yeah.
But there might be more of that one day. There might be, scarring, there might be liver spots, there might be sun damage, right?
Right.
So you probably need is a table for concerns that you can add to at any time and keep that customer concerns, but have it like the customer ID and the concern ID in one table. Because and plus one customer might have multiple concerns, right? So I think and the same thing goes for preferences. Doing like a preference table, and then you got clean ingredients, cruelty free, blah 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 underneath there, because there might be like who knows, like next week there might be like red dye number 5 is bad, or paraffin is bad, or whatever it is. So you might want like a preferences and a customer preferences, like this customer prefers cruelty free, whatever it is, right? So I think those add 2 more tables that way. I think that's good.
So instead of doing all this, just take it out and just say concerns.
Yeah, you have a customer ID, you have a customer concern ID, you have a customer ID and a concern ID.
Okay.
And then you'd have to make a separate table for concerns. And the same thing for preferences. Product form and consistency. Okay, let me follow. Okay. Tools and brushes. Fragrances. Okay. The reason I can tell that this is good is because it's like to granular details. Now we're not doing broad strokes. We're looking like refining it down. Like can you scroll down so I can see the other tables?
Yeah.
Customer info. Okay. Good. Invoice. Okay. Payment. Good. Are you missing like an items table?
Like this one, or
like here on your invoice here, we got invoice ID, price, date, time, item number, invoice number, payment, customer info. Where's your what item number are you referencing?
I guess I just assume that the products would automatically have an item number with them when they check out. Do I need to include the item number like in the column?
So okay, so you now let's talk about this. This is interesting. So you've got a tools and brushes table, a fragrance table, and a cosmetic products type. So what would stop them from being all one table and just have an items table or a products table in it.
That's what I was thinking. I thought that maybe they should all be one, like just one product table. But then
Yeah.
since they're like different categories, I didn't know, would I just like list all these rows in there or I mean columns?
So here's kind of what you would do, I think. I think you'd have just a products table. And that
Okay.
simplifies that down because basically anything you sell in the store is going to be a product. And then under that, you could have like a so you have a products table, and then you'll have like a category table, right? So then you have fragrances, makeup, tools, and brushes, right?
Oh,
So you have a product table, you have a category table, and then if you need to drill down even more, like refine underneath it, like if you need like for tools and brushes, you got a bunch of different ones. So you do like like a subclass. So you do product, category, and then item or something. I don't think I have a good word of it. Product, category, and then type. Product, category, and type. So you might have like a brush. So in a product, you'll have like a wet brush or whatever it's called, right? And then you'd have your category would be brushes, and underneath there would be like hairbrush.
okay.
So because when you look at your tools and brushes table, you've got accessories, makeup brushes, hairstyling brushes, combs and brushes, skincare tools. If you think about it, there's probably like 3 or 4 more things like you could you put there like eyelash curler or eyeliner sharpener or
Right.
case of. So you want to make you make this like growable. So if you added products, you would have to create a new table for it. You just add a new column, add a new item in the products table, or like
Okay.
like that. So so then and then so then then SPF comes into play on that one. Like so when you make a products table and then make a category table and type table, kind of consolidate in that to one table. And then attach that with to your invoice table. Now, see, so the other thing is you wouldn't necessarily directly attach it to your invoice table because it's a safe assumption that one customer might buy multiple things in their shopping experience with you, right? So you'd have to have a invoice products table to where the invoice number would tie to how many products were on that one particular invoice.
Okay. So I technically have like two invoice tables then because
You
one would have the product specifically or
Yeah, you have the invoice table, which has everything here. Like you have invoice ID, date and time of purchase. You wouldn't have item number there anymore. Invoice numbers, or you're duplicating that there, so you need that again. Customer name, stuff like that. But then you'd have another table called invoice products, right? And then you would have the invoice ID and then a product ID that would be tied to it.
okay. Cool. One thing I was also struggling with is I wanted to do like an enum on, I don't remember which one it was, but I couldn't figure out if I should or if the tiny ints were okay because the tiny ints are kind of like booleans, aren't they?
So here, when you look at this, a tiny int would be, well, a Boolean would be 1 or 0. A tiny int is any one character.
Oh,
But
okay.
because we talked about this table here with dryness, redness, these tables are going to go away
Okay.
because you're going to make the customer concerns table is going to be the customer concern ID, the customer ID, and the concern ID, and you're going to have a whole other table for concerns.
Okay.
So you're doing this. Imagine this like you got the front end application, right? So the customer, you're going through the customer, you do this questionnaire at the start. What are your areas of concern? And there's a checkbox, and you check the box of everything you're concerned about, right?
Right.
So you want to be able to make sure that you record all of those. So and you got, like I said, you got to think you might add more of those, one day. So you want to make sure it's very expandable. So you go ahead and so what am I looking for? You'll be able to, so it's much easier to add a row to a table than it is to add like a column to a table, because they have to redo everything. So yeah, so just make so same thing with the products, the preferences table. It's the same thing, you know, customer preferences table with preference ID, customer ID, preference ID, and the whole other table for all the preferences they may have.
Okay, so if we're talking about like the check boxes, because instead of like just choosing one, if they chose a checkbox, what kind of data type would that be?
So what it would be, so if you're, let me share my screen and do my whiteboard here. And we'll draw that out. Okay, so no, I did this last time. It wasn't good with the whiteboard. I don't want to do it with the whiteboard. I want to do it with Excel. So let me open Excel. That'll make it easier. I'll just share that out. Okay. Okay, so where did Zoom go? There you are. Where's my share option? Hello, sharing. That's not what I want. Okay, I want to share my Excel. Okay. Okay, so we've got over here, well, the products table. Okay, and then you have the product ID. Can you see my screen?
Yes.
Okay, the product ID. Let me make this a bit wider here. And then name, and then price, and then what other information you're gonna have, right? And then over here, you'll have, let's call this the preferences. And then we'll have, and so this will be int. And this will be varchar. Whatever, and then this will be decimal. Okay, and then I should spell right. And then over here under preferences, we're gonna have preference ID, and then we're gonna have preference. Okay, and then over at the customer table, and then we'll have customer ID, F name, L name, whatever else you can have with the customer. Okay. What was the other table that you had with redness and dryness and acne? What was that?
Let me look.
Let me do this.
Customer concerns.
Okay, concerns. Okay, that's what it was. Okay. So here with this here. So from this is the table here. Okay. This is the table here. Okay. So preference. This oh, okay, stop over here. Okay, so we got preference, and then we had concerns, right? So concerns. So we have a concern table with the concern ID. And then the concern. Okay, so for sake of argument, all the ID columns are int. Okay.
Okay.
Okay. Oh my gosh, I wish I could type. Okay, there we are. Nope, that did not do what I expected. Okay, concern. Okay, so we got these 4 tables. Now we want to know, we got a couple of things we do here. So we want to know what products here. So what preference is the customers have, but we also want to know what products have these preferences, right? So we make a table here. A table here, and we're going to call it product preferences. Okay. Okay, pref ID. And then product ID. And preference ID. Okay. And then over here, we're going to make a table called customer preferences. Oh, that was not what I wanted. So I wanted to keep that the way it was. Okay. So what we do now is my drawing here. Okay. So here, this. Okay. So we have these three tables. We got a product ID, a product table, a preference table, and a product preference table. And we got a customer table with a customer preference table, right? So what we're going to do is we're going to draw foreign keys. Okay. So now what this did was we have a table for preferences, what the product can do and what the customer wants, right? And we have it in such a way that we can add new preferences on the fly and not blink, right?
Right.
Okay. Now we've linked up, so we need to know what products fulfill these preferences. So we have this table here, which joins these two tables. We foreign key it, right? So nothing can exist here that doesn't exist here. Meaning, if I add a product here, right, it has to have one of these preferences. If I add a product here, in this table, this is where all the magic happens. Okay, so we can add all the products that I want, all the preferences that I want, and here is where they join up, because one product might have multiple. It might be anti-aging. It might be paraben free. It might be, and cruelty free, right? So we have all that lined up over here. And that way, one of these can match to multiple of these, and one of these can match multiple of these. Because we don't. If we try to do it this way, we connect the tables directly, we'd have many to many relationships, and that doesn't work. We want one to many. We don't want many to many. So here, one preference can belong to many products in this table, and one product can have many preferences in this table. Okay, so and this table is just three ints: int, int, int.
Okay.
Okay, same thing goes on here. I got a preference table, I got a customer table, I got a customer preference table, customer preference ID, which is an int, customer ID, preference ID. That way, one customer can have many preferences. One preference can go to many customers, and it all happens in this table here through the foreign keys.
Okay.
Taking beyond that, when you look at this setup, right? I now can say, I've got a customer who wants paraben free. I want to do a special this week. Paraben free stuff is 25% off. Get me a list of all the products and the customers prefer it, and send it to them. And you can do that through this join here.
Cool.
Okay.
So we did it that way because we don't want a many to many, and if we did, it would automatically make those tables, but we don't want that. We just want one to many.
Right. If we tried to do it directly like this, so if we did this way, right, we'd have to have a column in the products table that said preference ID. And how many preferences might it be? There might be 5. We're gonna put 2, 3, 10. We don't want to try to pound a many-to-many relationship because we don't know how many they're going to be. one product might have one thing, one product might have 12 things.
Right.
This way it's cleaner.
Okay, so when it's one to many, the many is the ones that are circled, right?
Yes. This is
Okay.
one to many. Oh, I can do it. Look at me. One to many.
Cool.
One-to-one works as well, right? So like if what would like we have a customer ID. Was it like if I can't think of one. Like if a product only had one preference, right? If it can only if product could only be paraben free, or product could only be cruelty free, then we could do a direct tie here. But the second where one of these can refer to many of these, and one of these can refer to many of these, we got to do a join table.
Okay. I see.
So do you see? So over here with the customer concern table, we're going to make a new table here, right? And call it customer concerns and do the same thing. So one concern can go to many customers, and one customer can have many concerns.
Okay. Okay, that makes sense.
Mhm.
So I just realized something. I put all my concerns and preferences connecting to the product, but should have I done that to the customer?
I just did that because that's the way it flowed. Because that was a logical jump for me.
Yeah. Yeah.
So I mean, it really kind of you might want to like rethink the concerns table and just make it a preference table.
Yeah.
Because cruelty free is a preference, but it's also a concern.
Okay.
So you may not need this concerns table at all, and you may just go in the preference table. And you want the preference table to match up, so anything that would be here would be in both of them. So if a customer concern is redness, this product solves redness. So
Okay.
you might want to keep customers concerned too, or however it works for you. Just different ways.
So even though,
go ahead.
sorry, go ahead.
No, go no,
So
no.
even though it's a customer concern, it doesn't necessarily belong to the customer. It's going to go to the product still, because it's like it's describing the product, kind of. Or
no, I think the way you did it, I think there need. Now I'm thinking about it again. I think there needs to be a customer concern table, because if a customer's concerned about redness, that's not necessarily something that's going to market a product. A product's going to be marketed for redness. So probably customer concern be a separate table.
okay. Does it matter which ones are left null and not null for this assignment, or because I did my best with that and I'm not sure.
This is your guys' first foray into designing a database. It will be graded with a very compassionate hand. So.
Okay, cool.
I mean, unless you do something blatantly wrong, like make an ID and event of varchar. Where nulls and not nulls fall is this project is not necessarily beyond the scope of this class, but it's like, it's kind of like challenging you guys greatly.
Okay.
But yeah, I'm not gonna like, oh, this is a null, I'm taking 10 points off.
So you didn't just need the ERD, right? You need we need to make up data and put it inside of it also. Okay.
So you need the ERD, you need queries to put data into the tables, and you need to write some statements to pull data out. So like, write the query that says, show me all the customers who are concerned about who are looking for anti-aging products, who and what products match up to them. So you want to write queries that are going to pull like data out to show me how it looks.
Cool.
And this way you kind of think up your own scenarios. Okay. And if you think of if you sit down and say, wait a minute, maybe the preference table shouldn't tie to the customer table, that's fine too. This is your. I'm just kind of, when I talk about things like this, I kind of like, this is how I kind of flow through the project, the design of the database.
That's really helpful though, because I was like I was wondering why I wasn't getting that extra table, because I thought that I couldn't remember, but many to many brings those extra tables, but I didn't necessarily want that.
Hmm.
So this is really helpful to see it this
Yeah.
way.
Yeah. It would be really cool if they found a way to automatically deduce many to many relationships and fix it on its own, but we've got to catch it.
Okay.
There's no AI for that yet. If it did, it would put us out of a job. We don't want that.
So I had my products going to my customer. That should be going to my invoice table instead, right?
Yeah. So your invoice table is going to kind of be like this, the center of all of this, because your
Okay.
invoice will tell you who bought what, when, how much it costs, and things like that.
And should the card information be connected to the invoice or the
So I,
customer?
so here's the other thing. So look at that. In a real world application, we don't store credit card numbers,
Oh, okay.
because that's when you start like having to announce we had a breach and someone stole all my customers' credit card numbers. So we let the customer store their credit card. If you've noticed, I don't know if you noticed, like it used to be that credit card numbers were stored by like the small applications, and now the credit card information is stored on your device and input into the application as it
Right.
goes.
Yeah,
I
I've
think
noticed that.
I think only like companies like the big kind of like Amazon, who are like well protected, they handle the credit card information with large companies, but smaller companies, you don't want that heat.
Mm-mm. Okay. So should I just get rid of that then?
What I would do is, so you do want a payment table. And the payment table would be, and let me stop sharing my screen so you can share back out if you need to. So the payment table wouldn't necessarily be like credit card. It'd be like forms of payment: cash, check, credit card, gift card, things like that. You wouldn't necessarily keep the card number, but it'd be like, was it a cash payment, a check payment, a gift card payment, or a credit card payment? And you might want to like, keep track. Is it Visa, MasterCard, something like that?
Oh, okay. So instead of being specific to the specific card,
Yep.
just have the types of payments you can
Yep.
do. So we discussed that I should do a product and then a category type. Is that
Right.
what we said?
So you'd have
Okay.
a product table and so you can go to inventory, products, items, what you want to call it, but everything that the store sells would be in there. Okay. And then you'd attach it to a category, and the category would be like makeup, makeup or tools or accessories or anything like that. And then you can further go down, like do type or further description and say like, if it's a brush, it's a toothbrush, or, it's a eyebrow brush, something like that.
Mhm.
So it's interesting when you look at this. So like fragrances, right? So when you deal with something like that, you've got men's and women's. So when you look at your products table, so you got a product ID, a product name, a brand, right? Then you'd need so then you would have like, I don't know if you put gender or whatever you put there, because it could be like male, female, or unisex.
Mhm.
So you need to call them there, because like for clones, men's clone versus women's clone, or I actually would know what you do. You'd have in your categories table, you'd have a men's clones, women's clones, and then all-purpose colognes or whatever it is.
Okay. Yeah, I
So
get what you're
instead of bringing
saying.
it, so you'd have that. So you want to be like, I want to look up all the men's clones, and we're going to assume at this point in time that there is not a women's clone that a man would wear and a man clone that a woman's would wear. I'm not sure on that, but I think it's safe to do that in 2021.
Mhm.
Same thing with brushes. Instead of like, it'd be like a makeup brush or a hairbrush or a comb or, whatever it is. So instead of having like instead of being columns, make those entries in the table. So, category 1, men's perfume; 2, women's perfumes; 3, hairbrush; 4, makeup brush; 5, sponge; 6, blah, 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 lipstick, eyeliner,
Right.
and then
So
accessories would be broad term too, like, makeup bag, purse, whatever it is.
yeah. So would I still have a brands table then if
Absolutely.
I'm assuming okay, and that would still go to the product one, just not the category one?
Absolutely. So
Okay.
you have a brands table that would go to your products table. Yeah. Because you want to
Okay.
know who made the thing.
Okay. Cool.
The odd layer out in this is, where would SPF fall into it?
Well, SPF can be in skincare and makeup, so I wasn't sure. So I was like, I could just connect it to the makeup, but I don't know. I was just grasping at straws because I was trying to get 12 tables.
Oh yeah, but as you see, it's easy when you start looking at these join tables. 12 tables becomes very easy.
Yeah.
So what I would do probably, I would add SPF as a column in the products table,
Okay.
and allow, because it'd be a number, right?
Mm-hmm.
And just allow like nulls,
Okay.
because if it was null, then it wouldn't have an, like a makeup brush doesn't have an SPF. So yeah, just allow nulls into there.
Okay. All right. So I think I'm gonna get rid of all the tiny ints. Is that okay?
I
Like,
think that's a good choice,
okay. All right.
because those tables are going to go. So yeah.
Yeah, because I even had it here with the tiny int because I think I
Well,
was trying to do like an enum here, but I just couldn't figure out how to do it.
when you say enum, what do you mean, like an automatic numbering?
Like when it gives you three choices and you can only choose one or the
Oh,
other,
right. Okay.
because
Yeah. Yeah.
you
Yeah.
can't choose a SPF that's 30 and a SPF that's 50 in one product. You only you have to pick one or the other.
So that's an interesting. So that's interesting. So you might want to. Okay. So here's here's an example where you have a one-to-many relationship or one-to-one relationship, right? So if you keep the SPF table where it is, right, and then add you have it here, the SPF ID identifier there, right? Hang on a second, I gotta plug my headphones. So one product will only have one SPF, right? So you want to keep that table. The reason I'm thinking about this, I'll explain why, is you want to keep this in a separate table, because if you have someone data entering and adding new products in, and the SPF is 50, and they fat finger it and make it 500, that would be bad. So if you have it in a table, and if you picture your application, there'll be a drop-down menu saying what SPF specifically you're looking for, right?
Yeah.
So what I would do is I'd keep the SPF table. I would add a column in the products table that says SPF int or SPF ID, right? And
Okay.
then I wouldn't make SPF tiny int. I would make it char 2. Okay. Because then you can have NA.
Okay.
Okay.
Cool. Awesome. That's really helpful.
I'm glad.
Cool. Hopefully I'll have it way better next time we meet.
This is a really excellent job. I mean,
Oh, thank you.
I'm assuming you've never designed a database before. But you know, for like a first crack, you're well to the point. Like, it's just like, okay, let's look at this and see where we can like condense things and spread things out. And you might want to, like, I would expand your customer info table, like actually have
Okay.
their address, email, phone number. You wouldn't have the
Okay.
invoice in there for customer info, because there'd be a customer invoice table.
So you're saying like not connect these ones? Is that what you're
No,
saying? Or
because
okay.
remember, one invoice, one customer might have many invoices, right? And one customer invoice will only have ever one customer on it, but you're going to have multiple items on that
Okay.
invoice. So you're going to make a customer invoice table, right?
Uh-huh.
And no, wait, hang on a second. Let me draw this out here. Let me make sure my
Yeah.
brain's going the right direction.
Do you want me to exit out?
I can exit out. Okay, so we got our customer table. Let's make an invoice table and see how this is going to go. So invoice table. So under products, we're gonna have price. So can I go back over here? Go to my inserts. Okay. I want to stop drawing, please. Home. Thank you. Okay. Okay. So let's do here. Let's make the invoice table. Okay, and then we're gonna have invoice ID. Invoice ID. Oh yeah. Okay. So this is what it is. So you have invoice table, invoice ID. and we're going to have customer ID. Customer ID will go here. And then we're going to have payment type, payment ID. Okay, so, and the reason why customer ID goes here is because an invoice will only have one customer, but a customer will have many invoices. So, and then we're going to have here, we're going to have invoice products, invoice products, and invoice products ID. And we're going to have an invoice ID. And we're going to have a products ID. And we're going to have a price. So now let's talk about this for a second and explain this. So, okay, we're going to have, go back to my drawing tools. So here, we're going to have, our invoice table is going to have a customer ID in it. Well, work with me here. There we are. Okay. It's going to have a customer ID in it, right? Because, like I said, one customer will have many invoices, so it can't put invoice ID here, right? But only one customer will ever be on an invoice. So I can put that there because that's a one dimension. So here's my one, and here's my many. Okay. Now over here, we're gonna have, and I'm not gonna put, I don't put price here. Okay. And I'm gonna explain this. So here we have invoice ID will go to here, and product ID will go to here. Now, we have price here and we have price here. Why would we put price here? Because technically this becomes redundant. It's in both places. The reason why we would do that, and we wouldn't put it here, is this price might change. So if someone bought something in January 2nd and it was $10, when they come back on January, when they come back on like February 2nd, it might be more money. I need to know what they originally paid for it. So we want to freeze that here, right?
Right.
Make sense? So over here on, over here, you know, sale date. Also, you'll notice that I didn't put a total column here in the total amount of the sale. Okay.
Yeah.
Because that could be calculated. Since the price is here, I can write a query that will calculate what the price was.
Okay.
Okay. We're not going to talk about sales tax. Just make it. We're in a tax-free world. Let's just worry about that math for right now. So we don't want to put the total in. We don't want to put the prices here because we're going to leave it over here, and that way we can just calculate a column on a query and say this is what the total was.
Okay.
So does that, so you follow logic why it's not invoice ID here, but it's customer ID down here?
Yeah.
Yeah, and then you've got this here. So, but the cool thing is, when you get the thing, you can just kind of watch how the data flows.
Yeah, that's cool.
It's like plumbing.
So when you say you freeze the invoice product one, is that kind of what we were talking about today with the transactions, like locking, or
no?
Okay.
No, so with transactions, that's a different thing. So let's say you're over here and you're updating the prices of your products, right? Let's say, you just got a new shipment of lipsticks in and the invoice came in 20% higher than it was on your last shipment, right? So you got to raise your prices 20%, right? So you can write a query that just automatically updates all the prices. Okay. Now what happens? So let's say there's no such thing as transactions, such as blockings and table locks, right? So let's say you're updating, I don't know, 1,200 different lipsticks in your database, and your customer is on your website and says, I want to see all your lipsticks, and they want to order some, right? So when they pull up the data, they're going to see like some with no prices because they're in the middle of being updated, some with higher price, some with lower prices. It's going to be a whole mess. It's going to be what they call a dirty read, right? So when you issue a transaction against database, by default, what happens is it looks at the resource that it's using and blocks that resource from anyone using it until it's done.
Okay.
Okay. So if you are updating, and generally speaking, these transactions take less than a second, you know. So let's say you're updating these tables, and just at the exact moment someone someone tries to select something, someone's trying to select something, you'll get that, you know, there was an error, please refresh the page. That's why you get those, because the data is being updated and they don't want to give you a dirty read, so it blocked you from your doing. So a transaction locks down a resource for X amount of time until the process is done. And there's three basic things that lock down. You do a table lock, which locks down the entire table. So nothing in that table can be touched until the transaction is done. It's like Thanksgiving dinner, right? You don't want to touch, and no one can touch the food on the table until everyone sits down.
Mm-hmm.
Okay, so that's your table lock. No food until, so nothing done. A page lock. So when information is brought from the hard drive into memory, a page in memory is 8K. So when it pulls the information from the hard drive into memory, because everything has to be in memory to be used, you can't affect data that's sitting on the hard drive because it's data at rest and it just doesn't do anything. You got to pull it into memory. So if you're looking at, you're just changing stuff that's on that one page, when that 8K, then that page is locked. So let's say that's like, let's say you're updating the table and you're updating mascaras that are purple, and there's like only 6 of those, right?
Mm-hmm.
So the transaction look and say, okay, yes, this could be a table lock, but you're only doing the stuff that's on this page. So we're only gonna lock this page. The rest of the table is there, right? Everyone can get to it. So again, Thanksgiving, we're at Thanksgiving, and we know that Aunt Sally likes the stuffing. You can touch anything you want except the stuffing until Sally gets here, and then you can have some stuffing. Is the food analogy working?
Yeah, it's actually working great.
Well, food analogies work because everyone understands food.
Yeah.
Okay.
Yeah.
Last one is a row lock. A row lock just locks that one specific row that you're updating. Okay. So tables, you're updating, you're doing there's like every aspect of this mascara has changed, and you're changing the price, you're changing the color, you're changing the preferences on it. All this other is everything's changing, right? So with a row lock, it says, okay, you're only using this one row. I'm just going to lock you can get everything but this one row. So if someone's looking for mascaras, they'll get everything but that one. Back to Thanksgiving table. This is where Sally sits. No one can go here until Sally says she's not going to be here, and then everyone can sit here, and then everything else is free. So that's kind of how that works. So what we're doing here, the reason why we keep the price here, which takes it in a different tangent, right now on March 17th, this particular product is $12, right? And we want to record that in the sale table because let's do different. Let's say it's $12, but the customer had a coupon of $2 off, right? So the product is $12, but they actually paid $10 for it, and that's what gets recorded here, the $10, right? So if they come back 2 days later and return it, and they don't have receipts, we can look up their sale, right, and say, oh, you paid $10 for this. We're gonna give you your $10 back, as opposed to what was paid here.
Yeah.
Okay, with what's stated. So we want to record the price that was actually paid, because this price here is volatile. It changes based on the day. Okay, well, not the day, but it changes based on shipments and inventory and customer supplies, blah blah blah. Here, it's already this is a past table. It keeps that price.
Okay.
Okay.
Okay. Yeah, that makes perfect sense.
Good. I'm glad.
Awesome. The food analogy is great.
Yeah, I used to make really obscure cartoon references, and like no one got them, so I just stick to food.
No, I like the food ones. Okay,
of course,
cool.
Now I want Thanksgiving dinner. So that's
Me too. I'm starved. Okay, well, I think that's all my questions for that. I don't know if you want to go over the content or whatever. I watched the video that you posted.
I actually just did.
Oh, perfect.
that's kind of why I did. Like, let's talk about this real quick, because I could have answered the question faster, but I figured I just do the whole transaction thing there, because I mean, transactions aren't a difficult concept when you're just thinking in terms of like, you can't touch this until I'm done. It's the 5-year-old mentality. You can't touch it until I'm done. I'm
Yeah.
gonna slap you away until it happens. Yeah. This is actually a pretty light week on work wise, because there should be. I haven't looked at the exercise, but I don't think there's any code in the exercises. Oh, there might be with the save points. There are save points. Yeah. No, so it's on that. Let's talk about that real quick in case you didn't grasp it, and whoever's watching it right now will understand it. With transaction comes. Did you in the video? Did you understand the concept of the write ahead log?
Say that again.
When in the video that I made, did you understand the concept of the write ahead log?
No.
Okay. So let me get my whiteboard out and do this. So we've got our. Let's not do that. Let's erase that. That didn't look right. Clear this. Okay, let's go clear. Please go away. Clear all drawings. Okay, so we've got our database, right?
Right.
That's our database. Okay, and then this is our log over here. Okay, so our customer wants to put input data into the database. So they want to add 25 rows, right? You would think how it works is that I hit enter and that information is immediately written to the database, because that's how it's supposed to work. But that's not what happens. What happens is, erase this out here, go away, thank you. Whenever you try to make a change, an update, an insert, or delete to a database, it goes, where'd my pencil go? No. Eraser, draw, text, nope, that erased it. Oops, I've lost my pencil. That's fine. Okay, so just draw. Okay. It goes to log first. Okay. So I'm inserting 100 rows into my table. Okay. So it's going to write everything to the log first. As it in the log, as it says error free, error free, error free, it then starts writing to the database on something called a buffer. Wow, this is really horrible. How do you do this? The buffer pool. Okay, so like when you're watching YouTube, and back when it was whatever the slower speeds, it said buffering.
Yeah.
And it still does. So what's happening is the application is waiting for more stuff to come down from the host to show more of the video, because there's not enough there. It's never really shown in real time, right? So the same thing happens in databases. If I'm making insert, update, and delete changes to my database, it writes to the log first, and everything goes, and there's a buffer limit, right? And when it reaches that limit, it starts writing it over to the database into the hard drive, right? Because the hard drive is when it's written in stone and can't be changed again until you change it, right?
Mm-hmm.
The reason why it does this, if I'm writing 100 changes directly to my database and something dies halfway through, when that server reboots, there's going to be 100. There's going to be like 32 of 100 changes that are recorded, and the other ones aren't there, and no one's going to know what is there, what's there that's not there that's supposed to be, right? So what happens is, let's say I'm writing these 100 to the thing here, and it writes the log, and then it writes over to the buffer. It writes through the buffer into the database, and halfway through, the machine dies and reboots on its own. When a database comes back up for the first time, it says, okay, here's my database. It stops at number 87. Let's look at the log and see what the log says. And the log says, oh, you're supposed to have up to 106. And it doesn't match up, right? So then what will happen is this: since we had a write ahead log, right? If those changes are still in the log and haven't been written to the database yet, they'll write it to the database, even after reboot. So they'll still get written over, and the transaction will complete and everything will be fine. But if the log says you're supposed to have 100 inserts and I've only got 87 of them, what it'll do is it'll roll it back to before those inserts started. So so it never happened. So it's like it's got a self-preservation instinct to not put data there that I can't confirm. Okay, so that's what the write ahead log is all about. So if I do like I said, if I insert 100 rows and something goes wrong, because it went to the log first and then to the database, on the reboot, the database will look at the log and say, is everything right? And if it says everything's fine, it comes up as normal. If it's saying, hey, you're missing a handful of rows, I have them here, let's write them to you real quick, and then you can come up and that's fine, that'll work. Or if it says, hey, you're missing rows and I don't have a record for them, we need to go back to the beginning of that transaction, and it rolls back everything from where it started. So you'll never have incomplete data on an insert. Does that make that clear?
Yeah. So is that like, does it do that so you don't like accidentally like insert the data twice? Like if it said, hey, I didn't get all the data, and then you're like, okay, well, I'll just send it again.
Right, right. So you know that you don't have to run it again.
Okay.
Or you'll know that if you run it again, everything will be fine. Or if you don't run it again, it'll tell you you need to run this again, or you will need to run it again. So
Okay.
you'll never worry that you have half-baked data. So with that comes a couple things. So when you issue this command begin transaction, right, and then you write your code underneath it, right? SQL, the engine knows, okay, we're starting a transaction. So whatever you're doing is going to be part of one transaction, right? And you can name it too. You can name it like, Sally. I don't know, I'm stuck on Sally Day. Okay, so now, let's say you're doing a giant, you do massive data changes, and you want to run this to make sure it works, but you don't want to commit anything, right? So you can say rollback Sally. Okay. So what'll happen is you've got like 30, 40 lines of code making like thousands and thousands of changes. The procedure will run the transaction, make all the changes, record everything, and if it doesn't error out, it'll automatically roll back. So it'll be like nothing ever happened. It's like a fire drill.
Okay.
Okay. You also have this command called commit. Okay. If you issue a begin transaction statement, it locks down everything that's in that statement. So if you're mentioning 4 or 5 tables, all those tables become instantly locked while that transaction is in effect, because this is an explicit transaction. This is one that you are telling it to do. Okay. If you do that and do not have a commit or rollback statement, those tables will remain locked until you issue them that command. So no one can do anything as long as the transaction is open. Okay. A commit command says, okay, it's good. Finally, so what it does over here, when you're doing a transaction and you leave it open, everything is written to the log, but nothing gets written to the database until you give this commit command. Okay. So if you run this with an explicit transaction, it'll write to here. If you say roll back up, just kidding, nothing ever happened, right? If you say commit, okay, we're good, go over here. This becomes invaluable in things like error handling, because when you have a transaction here, you can say if there's I forget what the command for an error is. You can say if an error happens, roll everything back. Okay. But if there's no errors, you can do commit the statement. Okay, but it's all based around this. It's all based around this transaction log here. That's the most important thing here, and this is what makes everything different, because everything to this transaction log gets written here first and doesn't go here until either, if you're in an implicit transaction, you just said run this and you don't care if it works or not, it'll do through the buffer. It'll write here. When the buffer is limited to reach, it'll start writing over here until it's done. If you make an explicit transaction like this, it'll write to here and it will not do anything until you tell it to do something. So it'll just stay here in the log until you tell it it's okay to bring it over to the database. Okay. Cool. The last thing you have is called a save point. What a save point is, if you issue that command, right? Let's say you're running like 10 different transactions, right? When you hit save point, it marks in the log and says, okay, we're doing stuff. Come here. Here's my save point right here, right? So everything you do after that is after the save point. And let's say you're doing your transaction, and suddenly you realize you made a mistake and you can't remember if like you updated the phone numbers the right way or the price and everything. So you can do roll back to save point. So even though, and this is the kind of fun part, even though everything's been written over here to the database, right? If you say roll back to state point, the engine goes, hey, okay, so all this stuff, we need to undo it over on the database, and it just undoes it. So it reverses you back to where you tell it to go.
That's cool.
Yeah, and it saved my butt a couple of times. I'll be honest with you. It's important. See, so you know, database engines are all programmed for survival. They don't want bad things to happen. So this transaction log is what separates man from beast.
Cool.
I really miss having a whiteboard, an actual whiteboard I can draw on. Although my handwriting is really not much better than this. I'll be honest with you.
Mine's identical.
Oh, good. So then you'd read what I wrote down.
Yeah.
But yeah, so that's where that comes into play. That's where the whole, you know, that the gist of the lesson was transactions and save points, and basically how that entire mechanism was. I never did. I did an entire like 40-minute video on how this stuff is done on the. I really like how the engine works and how it works behind the scenes and how it writes the disk and all of this stuff. So I've got to find that video and I'll post it. It's in my YouTube channel somewhere.
Cool.
But yeah,
I'll have to find it. Is it unlocked on there, or can you?
it's all. I
It's
think
on your YouTube.
I don't unlocking things is so confusing to me. So you'll like see videos of my dad as well as database videos. So I don't know.
Cool.
But yeah, it's there. I'll have to look at I'll find out what it is and post that specific link. But yeah, it's when I get into the whole thing about how data is stored and why indexes get fragmented, and yeah.
Nice.
It's sad that I find that stuff interesting, but you know, it's just
No, I like this stuff too. It's kind of cool.
yeah, just how the engine works is pretty interesting. All right, I think you're in a good spot for this project. You're doing really good.
Good. I hope so. Thanks for
Yeah.
your help.
Oh, no problem.
Cool. Well, I'll see you next week.
Yes, you will. Bye-bye.
Okay, bye-bye.